Alright, question number 16 in our Polynomials test review. A contractor designs a rectangular pool with a 3-foot walkway around it. I'm going to label that right now. I know that this walkway is going to be 3 feet wide all the way around. The length and width of the pool only are 3x plus 1 and 2x. Actually, let's do this then. Let's say the length of the pool is 3x plus 1 and the width of the pool is 2x. It tells us that's for the pool only, so that's the inside rectangle here. What are the simplified expressions for the length, width, and area of the pool and walkway together? So we're going to have to add this walkway to the dimensions of the pool only. And now we're going to go ahead and label this. We know that this walkway is going to be 3 feet across everywhere. So when you talk about width and length of the pool, you can choose either one of these as the width or the length. I'm going to say the length we're going to use is going to be this one. So 3x plus 1. Let's call this the length. And let's call this the width. You could flip those around and your answers are going to be the same when you get down to letter C, the area expression. Okay, so if we look at the width of the pool only, in this case the width is 2x. So we're going to start with 2x. But then we have to add the width of the walkway, and we're going to add the width of the walkway right here. That's 3. And we're going to add the width of the walkway right here, which is 3. So basically, it's going to be 2x for the pool only, plus 3 feet of walkway at the top here, and 3 feet of walkway at the bottom. And if you simplify that, you're going to get 2x plus 6. All right, let's take a look at the length. The length starts off as 3x plus 1. And we're going to do the same thing. To add the walkway, you have to add 3 feet to this side, and you have to add 3 feet to this side. It's going to be plus 3, plus 3. So in this case, we can combine these like terms together, and we get 3x plus 7. And now it says, what's the simplified expression for the area of the pool only? Well, we know that area is going to be equal to length times width, or width times length. You can flip those around. That means we're going to take our two numbers, width times length, or length times width, and we're going to multiply those together. So we're going to have 3x plus 7 times 2x plus 6. And now we're going to have to multiply those together. We've been doing that already. Binomial times a binomial. Let's get some more space here so we can do this. So we're going to have, this is going to be, let me move the equal sign over here, equal to 3x times the second binomial, 2x plus 6. And then we're going to take the second term of the first binomial, plus 7, and also multiply it times 2x plus 6. Now let's multiply this out. 3x times 2x, 3 times 2 is 6. X times x is x squared. 3x times 6, 3 times 6 is 18. X doesn't have to be multiplied because the 6 doesn't have a variable. 7 times 2 is 14, and that's 14x. And then 7 times 6 is 42. We've got like terms right here. And we can go ahead and write our final answer. We've got our final answer for the simplified expression is 6x squared. 18 plus 14 is 32x. And then 42 on the end. Alright, same process probably for number 17. Let's read it to make sure. Don't assume until you read the question. Question number 17. A photo has a 4-inch frame around its entire border. Given the expressions for the total width and height of the photo and frame together. So now this is different. That's a terrible line. This is different class. Now they're giving me the dimensions of the whole outside of the frame. And they want us to write the expression for the width and length of the pool only. So in this case, we know this frame is 4 inches wide. We're going to have to remove that. In order to get from the frame dimensions to the photo dimensions, we have to subtract the width of the frame from the total. So the width of the photo only is going to be, let's call this the width, and let's call this the length. Doesn't matter which one you do. But now if this is the width, we start off with 3x plus 6, and now we're going to subtract 4 from this side right here, and we're going to subtract 4 from this side as well. So we've got to subtract 4 twice. You can combine these like terms. 6 minus 4 is 2, minus 4 is negative 2. So our final width is going to be 3x minus 2. Then let's take a look at our length. Our length starts off as 3x plus 10. That's the entire frame. We got to get rid of 4 inches on this side and 4 inches on this side to get down to the dimension or the length of the photo only. So we're going to subtract 4 and subtract 4 again. These are like terms. 10 minus 4 is 6, minus 4 is 2. So our length is going to be 3x plus 2. Notice in our first question, number 16, we were given the dimensions of the pool and asked to find the dimensions of the pool and the walkway. So we added the width of the walkway. In this case, we were given the dimensions of the whole thing and asked to just find the dimensions of the photo. That means we subtract the width of the frame. And now what's the simplified expression for the area of the photo only? Now we're going to take our new binomials here and we're going to multiply those together. So we've got our area is equal to length times width. Our length is 3x plus 2. Our width is 3x minus 2. And now what we have to do is, let's just combine the binomials. 3x times 3x minus 2. And to take the second term of the first binomial, positive 2, and multiply it by the second binomial. 3x times 3x, 3 times 3 is 9, x times x is x squared. 3x times negative 2 is negative 6x. 2 times 3x is positive 6x. And 2 times negative 2 is negative 4. These two terms are like terms. They can be combined, but negative 6 plus 6 is 0, so they just disappear. And our final answer here is going to be 9x squared minus 4. There's our simplified expression for the area of the photo only. All right, last question here. Question number 18. Which expressions are equivalent to x plus 8, x minus 3? Class, the best strategy to solve these equivalence problems is to first take the expression that you've been given and simplify it, and then simplify every possible answer, and then check and see if the simplified answers match the simplified question. This is the easiest way and the one that'll give you accuracy for all 4 of these, since all 4 of these could be equivalent or just one of them could be equivalent. So you need to check every single one. So the way I would do this is I'm going to simplify this one first. So I'm going to do x plus 8 times x minus 3. Let's follow our rules of multiplying binomials. Take the first term of the first binomial times the second binomial, then take the second term of the first binomial and also multiply that one by the second binomial. X times x is x squared. X times negative 3 is negative 3x. 8 times x is 8x. And 8 times negative 3 is negative 24. And now remember, our two middle terms are like terms. So we've got x squared. Negative 3 plus 8 is positive 5. and then we've got minus 24. So this is our simplified expression for the question that's being asked. Now all we have to do is check each of these four and see which of these ends up being the exact same expression if we simplify them. Now there's not much room to work on this, so you probably have to work on this on the back. I'm going to color code these. Let's do green first. So this one is x times x minus 3 plus 8. Oops. Let me get that to be correct. Plus 8 times x minus 3. Okay, looks like I can multiply monomial times binomial. X times x is x squared. X times negative 3 is negative 3x. 8 times 8 is 8x. And 8 times negative 3 is negative 24. We can already see, class, this is looking just like our previous work. But let's finish it up. We've got x squared. Our middle term is the like terms. So negative 3 plus 8 is positive 5x minus 24. And you can see that is definitely equivalent, the same as our original question. So this one is good. Let's do the next one. This one right here, I'm going to color code that dark blue. So dark blue, oh wait a second, we don't have anything to do here because the dark blue one is already simplified. You can't simplify it anymore, and it happens to match exactly our simplified question. So that one is definitely equivalent. Let's take a look at the next one. Let's color code this one as orange. So for the orange one, we've got x squared minus 3x plus 8 times x plus 8. All right, this is already simplified. This is already simplified. Let's distribute the 8. So we've got x squared minus 3x. 8 times x is 8x, and 8 times 8 is 64. And I already can tell this is not going to come out the same as our answer, but let's finish this up. This is x squared. Negative 3 plus 8 is positive 5. It's looking good so far, but our constant is 64. So this one is not, I'll put an x here, this one is not, actually it's going to be confusing. You're going to think that's a variable. Let's just say this one is not equivalent, because it doesn't simplify to x squared plus 5x minus 24. And then the last one, let's pick light blue here. Take a look at this one. This one is already simplified as well. You can see there's nothing more you can do. There's no more adding or subtracting or multiplying or dividing, and clearly that does not match our original question, so that one is out. So for number 18, we found 2 of the answers were equivalent or the same as our question expression, and 2 of them were not. If you follow this strategy every time you get this question, you'll be able to work out, even the most difficult question, you'll be able to work out which ones are equivalent and which ones aren't.